So previously we looked in depth about simple generative classifier, naive Bayes. We looked at naive Bayes, and also discriminative classifier, which is support vector machines. Right? So we'll take a look at another powerful algorithm, which is a non-parametric. Right? Non-parametric. इसको कुनै parameter हुँदैन, no parameter, without parameter. It learns without parameter. Right? So which is the random forest, right? So random forest is an example of ensemble method, meaning that it relies on aggregating the results from an ensemble, ensemble of simpler estimators, right? So what this means is that ensemble, you basically train a lot of models, say different models, right? And then you aggregate the results, right? Average or aggregate, and then you come up with the final result, right? त्यसलाई हामी ensemble method भनिन्छ है. So this random forest is an example of decision trees in random forest. That's basically random forest. Right? It's an ensemble method. Right? Ensemble method. Somewhat surprising, the somewhat surprising result with such ensemble methods is that the sum can be greater than the parts. I mean, when they to सबै combine गरिन्छ नि, हामीले aggregate गरिन्छ नि resultsहरूलाई, यो individual models, and then it gives really good result, right? Okay, so it's rather surprising, right? Okay, and then the majority vote among the number of estimators can end up being better than any of the individual estimators. Right? So we'll see examples of this. Right? So let's see. Now, okay, let me run this. Okay, so let's see. Before we can understand random forest. Right? Random forest, we need to understand what decision trees are. Right? First, I mean, let's understand decision trees. Okay, because random forests are based on decision trees. Okay. So random forests are an example of an ensemble learner built on decision trees, right? Okay, so for this region, we'll start by discussing decision trees themselves, right? Okay, what is a decision tree, right? So decision tree is basically, extremely intuitive way to classify and label objects. You simply ask a series of questions designed to zero in on the classification. Okay, so here's an example. Right? Example case. Right? If you want to build a decision tree to classify an animal you come across while on a hike, right? You might construct a decision tree just like this one right here. Like that. So it's my first. Okay, so you ask a series of questions, and then for example, you ask, okay, the first, okay, you see a particular animal, right? You're a naya animal, hiking, while hiking, you see this animal, right? Maybe you take a picture of it, whatever, right? And you want to find out, right, what animal is this, right? Is that animal, right? And so somebody, might have, created this decision tree, and you can use that decision tree to figure out the animal kyo. Right? So for example, the first question might be, how big is the animal, right? How big is the animal? So if it is greater than 1 meter, right? How many? You go this way, right? It's less than 1 meter, you go this way, okay? Let's say the animal is greater than 1 meter, right? Okay, 2 rows, right? 1 meter, 2 rows. And then you ask another question, right? Does the animal have horns? Right? Horns, so yes, you go here, right? And then no, you go this side, right? And then if you, okay, so I mean, depending on, what answer you get, you get the answer, depending on the answer, okay? You take a certain path, right? So Islamic decision trees, decision tree, right? Decision tree. And then it's a very simple, simple algorithm, right? Okay. So the binary splitting makes it extremely efficient. In a well-constructed tree, each question will cut the number of options by approximately half, very quickly narrowing the options among a range of classes. Means अब तपाईँको हरेकचोटि के भयो, you are um, throwing away the possibility. Half of the possibilities are gone हरेकचोटि, right? So this is okay. So like a binary tree, a binary tree. Okay, so हरेकचोटि you are excluding, or you are getting rid of half of the options, right? So ultimately ended up a queue, so you it can go on. Your question को level बढ्दै at some point के हुन्छ भन्दाखेरि you have leaves, leaves भन्छ यो चाहिँ यो last को लागि leaf, leaf पनि भन्न सकिन्छ. Those are leaves of the trees, leaves. After that फेरि branching हुँदैन, there's a leaves हुन्छ. अनि then फेरि for example यहाँनिर maybe it's a fox, maybe just an example, right? Maybe a lion or whatever, right? So सबैमा चाहिँ यहाँ के भन्छ भन्दाखेरि there is a leaf मा पुगेपछि कुन चाहिँ animal हो त्यो आउँछ लास्टमा leafमा, है? So the branchesहरू भइहाल्यो हैन, leaves मा पुगेपछि. अनि then so you can use this tree to figure out. So you may take any path, right? So depending on the animal, right? So you can take any of the paths, and then you ultimately arrive at the animal, like which animal. Okay, so this is a form of classification. You're trying to classify maybe say 1, 2, 3, 4, 5, 6, 7, 8, right? There are 8 animals here, and you want to classify that animal among those 8 animals, right? Okay, so that is what classification is, right? Okay, so so I mean the trick is deciding which questions to ask at each step, right? In machine learning implementation of decision trees, the questions generally take the form of exercise splits in the data. That is, each node in the tree splits the data into 2 groups using the cutoff value. Okay, so here this is a very a simple example of a decision tree, right? Okay, so now let's use this similar kind of decision tree to classify some data. Right? Okay, all right. Okay, so consider this data, right? So we just created this data, right? There are 4 clusters as you can see here, right? Char data, right? Okay, so now we want to see how well a decision tree can classify these. Like it's your char regions, right? Decision tree, कतिको राम्रोसँग classify गर्छ. Let's look at that, right? So this is just creating the data. We're just creating the data here. And so what do we do is basically this is how it works, right? So if we run a decision tree on this data, right? के भन्छ भन्दाखेरि iteratively, right? Loop मा run गरे जस्तै. So first there are different levels, right? There are depth भनिन्छ. Depth 1, depth 2, depth 3, and depth 4, right? 4, right? Okay, so these are depth, right? So you can call it, for example, this one right here. So first, this is depth 1. You can call it depth 1, right? Depth 2, depth 3, and depth 4, right? This city, right? All right. So this city, you can go to any level, right? Any depth. Okay. So for example, your data, okay, how does it perform the classification, right? So what it will do is, okay, so at each level, assign the level of new region according to the majority vote of points within it. Okay, so for example, here first depth मा के भयो भन्दाखेरि अब यो एक्सिस मा मैले स्प्लिट गर्छु है, यो this axis right here, है. अब यो एक्सिस मा के गर्छ भन्दाखेरि now यसले यो गर्न सक्छ कि yellow or not yellow, है. Is the point yellow or not yellow, right? Okay, so yellow. Okay, so depending on that, right? So yellow is saying, okay, so yellows, so these are all yellows, right? And these are all not yellows. So so it figures out that okay, the line should be here, right? Yes, is split. So majority कता छ, majority यता छ नि त. There's some okay, यतातिर फेरि black points को majority चाहिँ, है. यो line भन्दा तल if you look at it, right? So there are more blacks than yellow, so it knows that where to put the line. Line कहाँ राख्ने, यहाँ राख्ने, हैन. So we have this line, right? So this split. So first pass मा, first depth मा, है, first depth मा चाहिँ, so yellow or not yellow, right? So so depending on that, right, it knows, right? You yellow cha, these are all not yellows, right? So now it can it draws like a second like you want to second one. Now this is already split, so there are no other colors, so it's done with this. See, so jati depth ma gaya pani it doesn't change because there are no other colors, right? Okay, so how about here? So here now you can do ux. Okay, it can, you know, split ux and split constructs. Okay, here you can check for green or not green, right? Green or not green. Okay, so this is training. Yes, a training way, that's okay, because we have given labels. This is supervised, right? So we also give labels as well, right? Labeled into right? So it knows that, you know, the what color the points are. Okay, so now green or not green, right? So green jati yata ayo, not green jati uta gaya, right? Okay, some greens there, but they are minority, right? So some blacks that they are minority, right? So majority vote on side, right? So you line tani, right? Second depth, the third depth, okay, again, and then so on. See, you can draw, I mean, this line and this line, so and go on. So depth on side, so it you know, it splits you know, progressively as a depth, right? So it goes on splitting. It goes on splitting, right? Splitting the data, right? So okay, so using, okay, so notice that after, okay, so you except this no one color, okay. Now that's basically, that's the intuition of how decision tree works, right? Decision tree, let's say, okay. Okay, let's try to use, you're saying figure, this is just saying, you know, illustration of how you know, a decision tree forms the classification, right? So let's actually use the decision tree. Use got it, right? So we can use decision tree from these from scikit-learn, okay, sklearn tree, okay, scikit-learn sklearn.tree import decision tree classifier. Okay, 1 second. Grab this. Okay, so decision tree classifier. And then tree equal to, now what do we do? First, this is the same basic 4 steps, right? So 4 steps. Step 1, import the model, which we did there, right? From sklearn.tree import decision tree classifier. Plus I'm import person. So second, what do we do? Anybody remember? Second man key also. We instantiate, okay, and then we third my key also.
Hyperparameter set person.
But it's my hyperparameter sign, right? So what do we do after that? After third step,
data fit.
Yeah, that's exactly. See, you do the step utilize. That's again, right? Here we're instantiating, and यसबाट आएको रिजल्टमा के हुन्छ, यसको यो जुन यसले चाहिँ के दिन्छ हामीलाई भन्दाखेरि instance of this decision tree classifier, है, जुन कि model, that is the model, and then we fit our data x and y, right? X and y, right? I mean x and y level पनि दिएको छ, feature पनि दिएको छ, right? It's a supervised algorithm, of course, right? So then we fit that model, this model, whatever model it returns, the model instantiate, it gives us an instance of the model, right? And then on that we fit our x and y, right? Very good. So tree is our model now, right? The model is a decision tree model. Okay, so now okay, so here we write a function. Actually, the author of this notebook has written a nice function which you can use to visualize, right? Visualize the you know, how well it did, right? So let's see. So you can see here, right? So the assembly decision tree, right? Decision tree, scikit-learn decision tree. So it ran you know, some level of depth. We don't know how many depth, how deep it went, right? But anyway, so this is the result, that a decision, one decision tree, right? Decision tree, let's say the result you. I mean, what do you think, Kisa? I mean, has it done a pass? So is it good enough? It's not perfect. It's not perfect, but
राम्रो छ।
राम्रो छ है, very good. Yeah, राम्रो छ. But there's a little problem here. है राम्रो छ, तर problem के छ? Can you figure out there's some problems here? है overall good, pass चाहिँ छ है, A चाहिँ छैन है, but maybe हैन it's pass. Okay, overall good job, but there's some problems. है problem के छ भन्दाखेरि, see now you see this strip here, यहाँनिर यो strip, यो सानो strip है, this strip, I mean they do not make sense, right? Okay, this strip, यो strips are है, so यहाँनिर के भइरहेछ भन्दा it's overfitting है, तपाईँ के हुन्छ भन्दाखेरि धेरै डेप्थमा गयो भने ओभरफिटिङ सुरु हुन्छ कि है, अब यो सर्टेन लेभलसम्म ठिकै हुन्छ हैन, त्यसपछि चाहिँ ओभरफिट गर्न सुरु गर्छ है, because there is no, I mean there's nothing that can stop है this from going any deeper है, so deep and deep जति पनि जान सक्छ नि हैन, त्यसले गर्दा के हुन्छ भन्दाखेरि यो चाहिँ हैन त्यसले त्यो जति डिप गयो नि अब त्यति त्यो मिहिन हुन्छ नि त, त्यति ग्रानुलर हुन्छ नि त हैन, अनि त्यसले गर्दा के हुन्छ भन्दाखेरि त्यसले नोइजहरुलाई पनि पिकअप गरिदिन्छ कि है, सो त्यसले गर्दाखेरि इट ओभरफिटिङको प्रब्लम हुन्छ है, डिसिजन ट्रीमा के प्रब्लम हुन्छ, ओभरफिटिङको प्रब्लम हुन्छ, लाइक यु क्यान सी क्लियरली हियर दिस यो सानो स्ट्रिप है, यो आई मिन हैन यो इट डजन्ट मेक सेन्स टु हेभ दैट स्ट्रिप हियर हैन, एक्चुअल डेटामा त अफ कोर्स त्यस्तो त छैन होला है, एक्चुअली यो त नोइज होला नि त हैन, नोइज, त्यो नोइजलाई चाहिँ नोइज एरर इन यु नो data collection, all these, right? So you're saying overfitting, so we need to find a way to overcome that, right? So if you're running, okay, so let's see, let's see if I can run this. Okay, let me run all the with us. So let's see. Okay, it's good. Okay, let's see. So one by the way, see one. Okay, so let's see. Still running. Right? You see the side, you follow see that side and deliver that. Let's see. Yeah, there you go. Level one. Level one, simply yoga, right? Which is good, right? Level one, my yoga, right? And then level 5, it's already overfitted. See. It strips over this clearly overfit virus, right? So which is not good, right? Okay, so notice as the depth increases, we tend to get very strangely shaped classification regions. For example, at a depth of 5, there's a tall and skinny purple region. See this one right here, right? This one, right? And then these, okay, that doesn't, okay, so that has to make sense for that. Okay. So so now okay, so even this is just at 5, you know, level 5 may say it's clearly overfitting our data, right? So now so how do we you know take care of that problem, okay? So decision trees and overfitting, okay, so such overfitting turns out to be a general property of decision trees. It is very easy to go too deep in the tree and thus to fit the details of the particular data, right, rather than overall properties of the distribution. So I'm going to say the generalization, right? That is what we need. We need our model to be general, which can generalize to new data, right? New data points. But if it's, you know, trying to fit the details of the particular data, then there's a problem. Right? It cannot generalize. It'll generalize by itself, right? Which is a problem, which is what overfitting is basically, and high variance. Okay, so let's see, what if we do, okay, let's order trick law, right? So let's see, so what if we do this, what if we split the data into 2, right? 50% 50% data, okay? So we run okay, we take 50% of the data here, and then 50% we split the data into 50%, right? randomly, right? Same distribution, same data, same distribution, same data, but we split the data into 50% data, 50% data, and we run a classifier, decision tree classifier, and we get different results. See, it's the result there. Same data, same distribution, is supposed to give more or less the same kind of classification. No, see, say yaneri strips are isma china. See the shapes are, the overall usage change bats, overall usage takes yellow. No, yellow is fine, green is almost okay. I mean, this one is also fine. And yellow, green say problem. So using this one right here. This one is also, khasi change bats. But you your region, right? There's some problem, right? So ideally, when you are running a decision tree classifier or any classifier, any model in the same in the data that's coming from the same distribution, you should get more or less the same and the same region and the same decision boundaries, right? But that's not happening here. Right? But what do? We let's see. I'll go serially. Right? So it is clear that in simply okay, let's see. The key observation is that the inconsistencies tend to happen where the classification is less certain. A genre classification less certain. The other inconsistency around, right? Because the so clear separation ma problem bhayo है जहाँनेर चाहिँ जो mix and match and mix भइरहेछ त्यहाँनेर चाहिँ problems है. Okay, so okay, अब हामीले के गर्न सक्छौं भने we can take the average of these, right? So okay, so let's see अब हामी के गरौँ भन्दाखेरि let's see okay, so this is a random state 0. So now this is randomly data select गर्दाखेरि random state 0 मा यस्तो छ about random state 100. Okay, so now we get a different, I mean it's the same data, but the distribution, I mean we take same distribution of data, okay? See, we completely different, okay, okay, completely different, the result. So okay, just as using okay, so now what we can do is if we can somehow average these results, then it produces better, right? It produces better, the overfitting say overcome okay? So let's see, so that's why we use some kind of ensemble of estimators, which is the random forest, right? So this notion that multiple overfitting estimators can be combined to reduce the effect of this overfitting, okay, is what underlies an ensemble method called bagging. Okay, I'm thinking also bagging. Okay, I'll show you what bagging is. Okay, so bagging makes use of an ensemble, a grab bag perhaps, a parallel estimators, each of which overfits the data and averages the results to find a better classification. Okay, the ensemble of randomization trees is known as the random forest. Okay, so okay, what is that? Hey, let's try to do that. Hey, so I'm looking at some this type of bagging classification can be done manually. Let's do it manually first. Manually random forest algorithm use nagarikan, right? Just manually bagging these different decision trees, right? So we should get the effect of random forest. Okay, let's see how it can be done either. So I'm looking at some that we import two models, right? Decision tree classifier, just decision tree classifier we already imported, but let's do it again. And then I'm bagging classifier. I do it. I'm looking at some now. We instantiate bagging tree classifier. And we create a bag. A bag bagging tree classifier. This time we tree and n estimator 100, max sample 0.8, and random score 1. Okay, so let me explain what this means. So let me show you by drawing. So so here we go. Clear it out. Okay, so now bagging. What is bagging? Hey, bagging ma ke bhairachha ni, है. So look at this code right here. Hey. So look at this code. Where is that code? Yes, so let's see. I'm going to copy and paste. Let's see if I can copy and paste. Either copy and let me try to paste it here. Hey, let's see. Either. So maybe here. I don't know. Let's see. Either. Yep. Okay. Right. So I'm going bag is equal to bagging classifier tree and estimate is equal to 100. Max sample equals 0.8. Random state go 1. Okay, so the user. Now let's try to figure out either. So so you can see that okay, n estimate is equal to 100. 100 what? 100 estimators. That means so we run 100, right? 100. Okay, 1, 2, 3, and so on. But you would have 100, right? So 1, 2, 3, and 100. Okay, so 100 of what? Each one is what? Each one is a what do you think? Guess गर्न सक्नुहुन्छ के model होला? हरेक yeah, which model is it? कुन चाहिँ model हो? Okay, हरेक एउटा model हो, 100 वटा model हो, हैन? Estimator भनेको model हो नि त, है? An estimate, number of estimators. So these are all estimator. Model भनेको estimator, estimator भनेको model, है? So what kind of estimator are we using? Look at the code.
Tree.
And a tree. So each one is what? A tree. Tree. Tree भनेको के हो? Decision tree जुन हामीले यहाँ instantiate गर्यो नि, हैन? यहाँ हेर्नुस् न यहाँ माथि. Tree भनेको decision tree हो, है? त्यसको यो instance हो नि, है? Tree is an instance of decision tree. भनेपछि each one tree हो के हैन? Tree model हो, है? हामीले कतिवटा tree model युज गर्यौ?
100.
100. है? अब यसमा एनएसमा के max sample 0.8. है? Max sample 0.8 भनेको के होला त? है? Max sample 0.8 भनेको can you guess? जस्तै अहिलेको केसमा हामी के गर्यौ? जस्तै यो भन्दा अगाडिको केसमा let me give you some hint here. है? जस्तै हामीले यहाँनेर हामीले के गर्यौ? भन्दाखेरि कति 50% of the sample लियौं अनि फेरि अर्को हैन अर्को चोटीमा अर्को randomly 50% of the sample. Like same distribution बाट. Like 50% of the sample, 50% of the sample. Similar. And यसमा हामी कति percent of sample लियौं?
80%.
80%. है. So हामीले हाम्रो total data बाट हामी के गर्छौं? 80% randomly, है randomly, है randomly select गरेर 80% लिन्छौं हरेक चोटी. भनेपछि 100 वटा randomly हरेक चोटी के गर्छौं? 80% लिन्छौं, है 80% of the sample लिँदै अनि त्यसमा त्यो ट्री रन हुन्छ, है अनि त्यसले हरेक each individual ले के दिन्छ भन्दा each individual tree ले हामीले के दिन्छ? decision boundaryहरु दिन्छ, हैन? The regionsहरु दिन्छ, है जस्तै हामीले यहाँ माथि गरे जस्तो. So each one will give a decision result दिन्छ. हरेकको आफ्नो आफ्नो result दिन्छ. It makes sense? So far making sense or not?
So,
yeah, okay, very good. Hey, okay, so अब यसमा random state भनेको यो चाहिँ यो seeding गरे जस्तो है, यो state 1 भनेको चाहिँ यसले चाहिँ so if you're using the same code हैन तपाईले पनि random state 1 मैले पनि random state 1 we should arrive at the same result because यसले चाहिँ is seeding here. So यसले चाहिँ यो किसिमको जुन यो हो दिन्छ कि त्यही डेटाहरु पिक हुन्छ है, त्यही डेटा random state 1 गर्ने तपाईले रन गर्दा मैले भन्दा so the same data will be picked, right? So seed, you guys know seed, right? Seeding it as though. Okay, all right, so so far so good. So this is called bag. So this is a bag, right? It's a bag of trees. It's a bag, right? Okay, so this is a bag, bagging classifier, which is a bag, है यो केसमा हामीले चाहिँ bag भनेको छौं यसलाई. Okay, यसैलाई bagging भनेको यही हो है, एउटा bag एउटा झोलामा है धेरै classifier has the है bucket bag, है. So far so good. Okay, अब हामी के गरौँ भन्दाखेरि let's move on further with this. Now what we do is this, where is it? Right here, हैन? अनि त्यो गरेर हामी के गरौँ भन्दाखेरि अब हामी के गरौँ? So where is it? Not here, right here, up here. Hey, so I mean, I'm going to fit hey, bag mami fit xy. Hey, bag mami fit xy. Okay, so whole thing is a bag. I know this whole thing is a bag. I know you pick your bag. Of your bag mami family x or y. Right, I'm data there. I'm train right, trainers. Right, trainers. Right, and fit by train by series. अब हामी त्यसलाई चाहिँ visualize गरौँ. Hey, let's visualize. Visualize गर्दाखेरि okay, के छ? Do you see much of overfit there? Overfit देखिन्छ खासै? Use the stripper त्यस्तो stripper देखिन्छ कि देखिँदैन? के छ? Is it better? यो ठिक छ कि यो र improve? Is this an improvement on this one? जुन यो त्यस्तै भयो यो हैन? जस्तै यो यिनीहरु भनौँ न अब यो है यो okay. Is this an improvement? Can be. Is this the right? Is the stripper China? Hey, okay, you can see there. Hey, so it's much better. See, overfitting almost gone, See, and it has done a very good job, a very good job. See, right? So means overfitting China. It's a clean separation, right? Almost so it is some slight fancies is the problem, so that we can ignore that, but overall here it's much better, right? It's much better. Okay, so so now how were we able to improve the result? And we improve result improve right? So how did it improve? Can you try to you saw all this process, right? Okay, so what did we do? Yeah, anybody want to try? कसरी भयो हामीले के गर्यो हामी त्यस्तो के जादु गर्यौं कि हैन now it's overfitting is gone and it's just a nice yeah, please try. Yeah, so try. Yeah,
multiple model गर्यो अनि त्यो हरेक मल्टिपल मोडलमा चाहिँ हामीले random number of samples randomly choose गरेर चाहिँ different मोडललाई ट्रेन गरेर चाहिँ अनि तिनीहरुको aggregate रिजल्टलाई चाहिँ जोडेर अनि
yeah, exactly. Thank you. Right, your colleague oh, he was with this. Oh, okay, very good. Okay, excellent. Hey, so yeah, this is ensemble. That is what ensemble is. Right, you run different models, right, and then final result is aggregation, right? So it's an ensemble of methods, right? Random forest right? Random forest we run multiple decision trees with randomly selected data in every classifier or decision tree classifier, and then each one will give its own result. And if you sabai result collate or aggregate average aggregate and it will give you the final result, which is much better than the individual. Right? Individual one there. I mean, the sum of parts is more than the whole. The sum of parts is more than the individual one. So that's what it is. Right? So this is random forest. Right? Random forest game. Right? So okay. So I'm going to end it. Please join. Join back after this.